Okay, if you want to pause the video, have a go at this question and then press play. Or if you want some hints, just press play if you think. Right, let's have a quick go at this question. Here goes: the variable x has distribution. So I'm going to just write this: x has a normal distribution with a mean 20 and variance as 9. So it goes find the probability. So A. Now this question you just straightforward in your calculator. So it says find probability of x is greater than 25, and if you just put that through your calculator, just type it straight in using the menu 7 function, and you should get the answer 0.0478. Okay, now again with B, it's just straightforward. Put it in your calculator. This one you're doing inverse. Okay, so you're doing inverse normal distribution, where you've got to put the probability in first. Now just be careful, because some calculators, especially my calculator, you might have to, because it's greater than, you might have to use, instead of 0.2, you might have to put in the probability 0.8. I'm just going to double check it. So if we go into 7, inverse probability, put the area 0.8, put in the variance, well, standard deviation, which will be 3, square root of 9, and mean is 20. And yes, you'll have to put 80, so you'll get an answer A to B. So this A has to be greater than 22.5. Okay, to get you the area of that. Always note that normal distribution has a bell like this. It's told you that the mean here is 20, the average. So we're looking at a value here, something greater than that, which in this case is 22.5, and any value above that will give you a probability of 0.2. Okay, so let's look at C. So it goes here, find B such that you have this. Now again, if you draw this from this one, if I draw the normal distribution, and if you put 20, which is in the center, and you've got this value here, let's say that's 20, that'll be plus B, and that's going to be 20 minus B. This area here between there and there is told you is 0.5. Now you should know that the area under the whole graph is 1, so this area here is going to be 0.25, and this is also 0.25 because it's symmetrical at the center. Okay, so if we choose one of these probabilities, now you can do any one, so you can choose whichever you want. I'm going to just go for probability and call it this value. I'm just going to say x is greater than k. Okay, and that's going to give me an area of 0.25, but I'm putting in my calculator well, let's say 0.25, but when I put it in my calculator, I'm going to put in, so I'm going to put calculator here, I'm going to put in, when I do inverse probability, I'm going to put in the area 0.75. Okay, and in your calculator, this value will be given as 22.023, etc. Now don't forget this k value here is this, so let's call that 20 plus b is going to be 22.023, etc. So b, and I'm just going to do it to free simple figures, is once you take off 20 from there, will just give you 2.02. Okay, that one's done. Let's have a look at, so this is part 1. Let's look at part 2. Goes here. Now the variable y has this distribution, so I'm going to just write down y as a distribution of mu, and this is going to be mu squared. This is the variance. Now notice that if that's the variance, sigma, which is standard deviation, is just going to be mu over 9, over 3, because you just square root that. We just remember that bit. Now, we know that the probability that y is greater than 1.5 mu. Okay, we need to find that probability. Now, when we're doing this, the best way to do here is what we call standardization. Okay. And the way to do standardization, you do x minus the mean shared by standard deviation, and in this case we will get 1.5. So in this case x is 1.5 mu. Then we take away the mu, which is the mean, and we divide it by 1/3 of the mu. Now that will give me 0.5 mu over mu. Now the divide by 3 I'm going to take to the top, so that goes to the top, and note the mu's will cancel here, and 0.5 times 3 is 1.5. So by standardizing, we now got y. With the standardization, we moved it to a normal distribution with a mean of 0 and a standard deviation, a variance of 1. So now I can just use that to find out the probability of the standardized mu. Could call that z actually, because that's what we call the standardized mu. So we know that in z, we need to find the probability of z when it's greater than 1.5. What is the probability of that? Now if you just put that in the calculator with these conditions, standardized conditions, you'll get a probability of 0.0668. I mean, I've done that to 3 swing figures. It does carry on, but we're okay with that. Alright?